we are checking the analysis, checking the model. There will be joints, tolerance, and the joints may be at the joint, either the joint is being provided properly, the joint in frames, either we have assigned correctly, and joint in cell. So all the joints will be checked with a tolerance limit of 1 mm. So it will check up to the accuracy of 1 mm. Also the frame overlap, we have splitted and divided the frames into number of components. So it will check that either the frame is overlapping, either do you have any intersections within the tolerance, intersection within area of edges. So these are the checks for frame and shell overlaps, provided the floors properly at the edges. This is the check. Then other checks are meshing. So we have not generated any mesh for this. If we have not generated, what will happen? It will automatically take the meshing distance. So let me explain about that and check for loading on all stories. Since the Etabs covers dead load, even though if we are not applying the load, it has some self weight. So self weight is going to be taken automatically. So no need to give the self weight of the material. Whatever we are including apart from self weight, we have to consider. Check for duplicate self weight mass. These things we will be checking, and let us check this model. You can see here whatever is happening and what is the current status. It will be displaying here. Now it's ready. The model has been checked and no warning messages. If we are looking at our structure, what are the loads apart from the self weight? We have applied column, beam and slab. These three things we have applied. And when we are looking into other than self weight, what are the loads we have? We have the wall loads. At all the perimeter of the building, we have the wall which is 230 mm thickness. So let us apply the wall load, and we will be providing flooring. So it might be a tile or it might be a concrete floor. So after the self weight of the concrete, we will be applying some super dead load. These are all called super dead load. So this should be added, and live load, including the self weight of human, those who are occupying the house. Everything will be covered in, and the live load which is having a separate code book. IS 875, we have a separate code for that. Part 1 specifies the dead load for each and every material. Part 2 gives the live load. So for a residential building, let us have a live load of 3 kilonewton per meter square. For going for any commercial building, we will be having 4, and in case of any library storage structure, it might be a cement storage or goods storage. If we are having like that, we will be having 5 kilonewton per meter square. So as of now, since we are constructing a residential building, 3 kilonewton per meter square is the maximum. For each and every room, we have separate live load. So right now we are not going to that much detail. Veranda, you will be having different kind of loading. It might be 4 kilonewton per meter square, and in bedrooms you will be having around 2 kilonewton per meter square. Whenever you are having a toilet or the private spaces, you will be having around 1.5 to 2 kilonewton per meter square. So these are the average live load which is going to vary according to the rooms. So in an average, what is the maximum load which we can take is, we can take 3 kilonewton per meter square. Let us consider the live load as 3 kilonewton per meter square, and in a staircase you will be having, so since we have only included the slab for a staircase, you can observe here, the last class we have included staircase here. For a staircase we have only provided the self weight. For providing the self weight, we have the slab depth and thickness only. After the construction of slab, the staircase have rise and thread, so which is not covered here. and these loads will be super dead load. So we will be adding dead load, super dead load, live load. Okay, you can observe here that we have only provided the slab, and this weight will be taken automatically. Now super dead load will be applied. What is super dead load? We will be constructing either in brick or in concrete the rise and thread for each and every steps. This is called super dead load, and above that we will be having a live load. Live load can be up to 4 kilonewton per meter square. We can take it. We have to apply in the flight as well as at the landing. So at both the landing and flight we will be applying. So how to calculate the brick quantity? So let us calculate now. And brick will be having a self weight of 17 kilonewton. What will be the length? So we have a total length of 3.8 meter at one side and 4 meter at the other side. So let us consider 1 meter multiplied by 1 into the height. The height of the floor is 3 meter. Hence we will be multiplying into 3 into what will be the thickness of the wall? It will be 230 mm. That is 0.23 mm. If we multiply here, we will be getting 11.73. This is our dead weight. That is super dead load, and we will be applying on the beams. So 11.73 per meter. Okay, beam, and let us join from this to grid line. Yes, this is the only missing part. Let us define the load patterns. We can go to here, and what are the loads we are looking into? We are looking into super dead load, super dead, let it be, and the type will be super dead here. Self weight multiplier will be 0, and let us add new load. Then let us add a live load is being automatically applied here. As of now we will be using dead load, which is the self weight, and live load we will be using finally super dead load. This super dead load will be having the floor finishes, wall weight, etc. Let us press OK here. Go to plan, basement, apply. If the beams are not jointed, I am joining all the beams. Yes. Now let us assign the load. We can check here that 17 frames is being selected, and this will be the 18th frame. Whatever we have selected, it should be visible here. Yes. Let us assign the load now. Load will be 11.73. You can name it as super dead load and replace the existing load, and you can apply here. Yes. Then press OK. Go to the plan and first story. apply. We can see here that only at these portions you need the load. One frame, the beam is missing here. Here you can see B16. Here there is no beam. Let us assign the beam. Now select the beam where you need to apply the wall load. Yes, we have selected the beam. Okay. Now let us check in the 3D. Here you can see these two frames, the load is missing. 1, 2. Once if you check into 3D view, if any assignment is not provided, you can do it here. Yes, now it has been assigned. Okay. Also you will be having a parapet wall. In all the first floor you will be having a wall which is having 1 meter for safety purpose, and throughout all the first floor you need to apply the parapet wall. If you are having at first floor and this is the second floor, if the structure needs a second floor and the opening at the second floor, you can add the floor here, and the staircase can also be extended up to here, and you can add a parapet wall. So as of now we will be only providing the parapet wall at the first floor only. So parapet wall will be sitting at these areas. In the perimeters you will be having parapet wall. In the interior you will be not having the parapet wall, hence you can deselect this. So in all the perimeter you can select. Now these are the area where you need parapet wall. Okay. Now when applying the parapet wall, it will be in a height of 1 meter only. So for that you can calculate the unit weight is 17, brick unit weight is 17, and you are going for 1 meter, height is also 1 meter, and thickness is 0.23. If you multiply, you will be getting 3.91. So throughout this area we will be providing 3.91 of load. This will be assigned as super dead load. Apply. Okay. Now this frame is being not applied with the load. Now at the staircase, we can check here that at the staircase we have to apply here. At the staircase also we will be having a beam In this beam we will be having half of the brickwork. 5 feet height you will be having the wall. 17 kilonewton per meter is the unit weight, and for 5 feet we can calculate it as around 1.52 meter height we have to provide. Okay, this 1.52 meter height into 17 into 1 into 0.23, which will give the self weight at half of the area. Since you have this beam and half of the load will be here, half of brickwork will be here up to 5 feet. So it will be around 5.96. Let us take 6 kilonewton per meter, and let us assign the load here. 6. Let us apply. Yes, it has been applied now. Now let us apply the slab load at the first floor. Let us apply. In the first floor, the slab load will be assigned. All the slabs is been selected, and let us assign shell loads as uniform. Uniform shell load. Let us assign two types of loads. First one is live load, 3 kilonewton per meter square in the direction of gravity we are applying, and it is shown as 3. If we need to remove the beam and frame label, we can remove that by going to options, and let us remove that. Then a super dead load, which is having a floor finish. If you are having the floor finish load, also can be applied. It has been taken as 1 kilonewton per meter square. Apply. Okay. Currently it will be easier to view. What are the loads we have applied? We can check here. We have applied a live load. I am applying, I can see at all the areas we have applied 3 kilonewton per meter square. At all the areas we have applied 1 kilonewton per meter square of super dead load in the first floor. We shall apply the floor load, that is the roof. Assigning the shell as the roof load, we can apply. In the roof we will be not having any live load, we can apply only the super dead load, roof finishing, and let us take it as 2 kilonewton per meter square and apply. Here we will be not having any live load. Okay. Now we can view that. In frame we have not applied any live load, and super dead load we have applied at all the areas and the perimeter. If we are extending the staircase for the second floor, we will be having a parapet wall here, and we shall apply the load for the respective cases. Now in staircase we have to apply the slab load. We are selecting all the staircase slab. Okay, in 4 shells, in these 4 shells, let us apply. What are the loads will be coming in staircases? The rise and thread. We will be constructing in brick or in concrete, and the live load. So, two types of load we have to apply. Then assign shell loads, uniform, and let us apply this as super dead load, which will be the rise and thread of a staircase. Let us take it as 2.5 as super dead load. Apply, and we have applied here. And if you need to apply the live load can be applied up to 4 kilonewton per meter square. We have selected all the members. Then apply. Okay. Now the live load has been applied in the staircase. If you are not having any rise and thread in these two portions, you can eliminate that. This is super dead load. So whatever super dead load we have given, we can delete the existing load. So in this way we can delete the existing load, since the rise and thread will be in flight only. Now at these two portions you have super dead load, and here will be having a floor finish. So for floor finish purpose we can add a super dead load. It can be around 1.5 and apply. Yes, the variations we can show here. Fine. So currently we have applied the loading. After loading, let us check the model again for all the cases. Now the model is being checked and no warning message is being generated. Okay, this model can be now analyzed. Okay. Now before analyzing we have to define the load cases. What are the load cases we require? We have given dead load, live load and super dead load. These three cases will be applied here, and let us go to load combinations. You can see if you have a well defined code books. So initially we have assigned IS 800 and IS 456. In those code books, what are the combinations given for dead load, live load? Those combinations will be automatically placed here. You don't need to give any combinations, but if you are using another software, example a stat pro, you have to do your calculations and check for the load cases. But here this is automatic. You can see here that 1.5 times only dead load and super dead load, and another combination will be 1.5 times dead and 1.5 times live. So these two combinations are according to Indian standard codes. It will be automatically applied and the load combinations will be taken. We have applied 2 kilonewton, 1 kilonewton at each and every portion, whatever the load conditions are here. Analysis of slab, analysis of beam and the frame. So for all the cases you will be having analysis, and let us run an analysis first. You can see here that analyzing a model, preparing to run. Now your analysis is over. You can see here the deflected shape, and if you start the animation here, it will show the deflection and the way it is bending. Let us stop the animation and let us check the deflection here. At each and every point you can see the deflection. You can see a 3D view, displacement as dead. So what is the maximum displacement due to dead load is 0.936 mm. What is the minimum and maximum? So the maximum is created at 7.1 in x direction, 7.2 in y and 4.5 in z direction. So at this point you are having 0.185 of maximum dead load displacement. Okay, let us check the shear force and bending moment diagram. For if you are only applying the dead load, what will be the bending moment? You can see here that these are the values which is occurred for dead load bending moment, and you can see maximum. If you need any detailed information, you can click this and right click. It will be showing this beam complete analysis. You are seeing here that a beam which is having a fixed end, you are having support reactions and a fixed end here. You can see the bending moment at each end, the shear force, moment at third direction, x, y and z. Deflection at this point. You can see a deflection of 0.036 mm at 1.422 meter. For live load, you can see here for dead load it is 4.64 and 7.88. For live load it is going to change, and for super dead load you can see the difference. So at each and every point you can find the bending moment and shear force. Okay, why we are having less number of bending moment here is since this is the staircase area, you will be not having any load. Here you can see less bending moment. Let us check for live load. Live load has been only applied at the first floor. Why? Because this is the floor which has been casted in RCC, ground floor which will be having, if you are casting any RCC slab in the ground floor, you can apply the load here and this load will be transferred to the beam. So as of the ground floor, it will be applied with PCC and the load will be directly going to the ground. So you no need to give any live load here. So live load will be only applied at these portions. And you can see due to live load the column bending is also shown here, and due to super dead load you have the load. This is the bending moment and shear force. What are the other things we can get here? That reactions. Reactions are very much important in designing the foundation. When you apply point loads, when you apply dead load, so what are the reactions? So let us check here. In plan it will be very much easier to observe. Let us go to plan. Yes, at each and every point we can see the reactions. What is the maximum load coming to this column is, you can see 114 and 166. These are due to dead loads. The reactions what we have applied currently is due to dead load. What is the maximum reaction? the building is totally carrying around 195. Here you can see 195, and this is 143. The maximum Z. What do you mean by FZ is the vertical load which is coming to the building. At the base of the building, the reaction is maximum reaction, which we are going to find. We very well know that we are having two number of floors in this area. Hence, we will be having maximum reaction at these areas only. We can see that column number 12 is the critical column. 195.03 of F Z is being taken here. You can see 166, and the staircase column we have provided. This column carries only 43 kilonewton. That is why we have only assumed 230 mm by 230 mm size. We can take the same column, that is 1 meter by 1 meter, but here we can see that the load is very much less. The 166 which is occurring at the side, and at another side you can see only 43 kilonewton, and FZ at this column is 93. We can see this critical area 166, 43, 93, and here you have 195, 25 and 111 kilonewton. This is around 10 tons of load which is occurring, and around 195 tons of load due to only dead. Due to only dead load, you are carrying this much of amount of Z. And regarding the moment, you are having in Y direction. This is X and this is Y direction. In Y direction, you are having a high moment of 12.32 kilonewton, and at all the portion you are having less numbers. But here in X direction, you are having 17.226. So these are the notable moments. If you are looking into live load only, let us apply this, and we can see that due to live load, the reaction is very much less. Around 192 kilonewton of load was here, but due to live load only 43.6 kilonewton of live load. You can have a look in each and every reaction. So to design, so here itself in analysis you can look into the reactions forces and you can make the design adjustment. And due to super dead load, you might see that 170 kilonewton of load which is the maximum, and at X and Y you have the respective load here. Now let us check the load combination. This will be very much higher than the previous. So due to dead load and super dead load, this is the first case, and UD concrete 2. This is the second case, which is 1.5 times dead, 1.5 times super dead load and 1.5 times live load. This is the critical case. You will be having the maximum load here. You can observe here that 613 kilonewton of load. This is the maximum load due to the load combinations which might occur. If you see the dead load, it was only 193, but due to all the load combinations, the reaction is 613. Around 61 tons of load which is being carried by this column. You can see the moment which is considerable. You are having 34 and 16. So in X direction you are having 37. So these are the considerable reactions which you can find the critical section. And if you are looking into the plan, rest of the area you can see much lesser. FZ due to all critical is 2 times reduction. Here you can see the moment. In which point you are having maximum moment is moment of 43 in MX, and in MY the maximum moment, let us check that, 35 is the maximum. So you can get the maximum and minimum moment. So you can get to know that this building is totally carrying a maximum load of 61 tons of load and in a single column, and this is the critical column. Okay, how much this section is deflecting? So let us check that. Let us check in the displacement. So the displacement due to combination, this is the critical combination. We can check here. Yes, you can see the deflection here. At each and every junction, the deflection is available. You can see that UZ is minus 3.93. This is the deflection at this floor, and at each floor you can see the deflection. So the maximum deflection where you got is minus 3.293. If you are making finer mesh, you will be getting much higher and much finer value. So you can generate mesh. In the topic of slab analysis, I will discuss these things. How you can mesh the slab so that you will be getting maximum deflection. So according to this kind of meshing, you are getting a maximum deflection in terms of mm. So these are all in terms of mm. The maximum mm due to all the load combinations, here you can see it as 6, that is plus 6 and minus 3. Also you can see mode shape. Mode shapes will be used only when you are doing dynamic analysis. Right now we will be not going too much in that. So as of now, today's class is about how you are applying the load, what are the loads to be applied, how you will be getting the analysis result. What are the important result is the reactions. What will be the reactions for the BE civil engineering students? They will be studying in second year regarding the reactions, how to find the reaction, how to find the bending moment, which is covered in strength of materials, mechanics of solids. It might be determinate structure and indeterminate structure. The whole two concept of the subject which covers only these two concepts. What are they? That is finding bending moment and shear force, finding the deflection and reaction. These things we have calculated in an absolute manner for load combinations also. Understanding in analysis gives you good design. So that is why design engineer will be in much higher level. Why? Because first level of understanding is modeling. If you are well versed in modeling without any free errors, this is the first success as a designer. And second success is making a good analysis. What are the possible loads which can occur and what are the possible ways which you can get the analysis. So in all the aspect you have to do. When you are doing this, you will be getting this reports, analysis report. By getting this analysis report, you have to design the member. So which will be discussed in next.